So this is the second video of section 8.4, logarithms. And I'm just going to do a few examples using the property that I stated on the previous page. Not the domain and range stuff, but the fact that log base b is the inverse function of an exponential function base b, and vice versa. So they have these little exercises that are pretty standard, traditional exercises where you just use those rules and you rearrange stuff. Now, sometimes in a high school class, they teach this to you as just rearranging numbers. That's not a smart way to do it at all. It's much better to use this F and F inverse property. In other words, you're getting something to cancel, kind of like subtracting 1 from both sides of the equation, or dividing both sides of the equation by 2. So you'll get a lot further with this if you do this way, okay? It's actually quite simple and it's hard to forget. That's the most important thing. So I'm trying to write as a logarithmic equation 3 to the 4th power equals 81. We consider that to be an exponential equation, even though 4 is a constant. It's think of it as an exponential form. It's written as in a form where there's an exponent, okay? And they want you to write it in a form where there's a logarithm. That's what it means by write as a logarithmic equation. They just mean write it in a form that's a logarithm. Now, this is actually what's called an identity. 3 to the 4th is always 81. It's not really the typical equation where you're trying to solve for a variable, right? It's something that's always true. That's what we call an identity, something that's always true. So you're not supposed to just multiply 3 to the 4th because that just gives you 81. Isn't that a very interesting problem? So you're supposed to write this with a logarithm. That's what it means. So what you do is, since logarithm base 3 is the inverse of exponential function base b, I can take log base b of both sides of the equation. You have to, just like with everything else, you have to take log base b, or log base 3 in this case, of everything on the left and log base 3 of everything on the right. If there was a sum on the right, I'd have to put it in parentheses and take log base 3 of the whole thing. You can't, it's not multiplication. You can't distribute a log base 3. You can't take log of the first term and log of the second term and expect that to work out, right? You have to do log of the whole right side. In this case, it's just a single number, so it's no big deal. So log base 3, oops, I pressed the wrong button. My apologies. There we go. Okay, so there we go. Take log of both sides. Sorry, I just pressed the wrong button when I was doing this. Log base 3 of 3 to the 4th, right? I took log base 3 of the left, log base 3 of the right. So that's log base 3 of 81. Now I'm not trying to figure out what that is. I just wanted to write this with a logarithm, which I have. But now I want to simplify this, because this obviously simplifies because these are inverse functions, and I get a 4. So I'm going to get 4, right? The base 3 and the log base 3 cancel. And you get 4 equals log base 3 of 81. Make sure you understand this example before moving on and compare with the previous video, or pull out the PDF and look at the page on the previous page and compare it with what I just did. That's one way to compose things. Now, you can start with the logarithm and turn it into an exponential equation, or an equation in exponential form, some people say. Okay, and that's what we're doing here. And I could have taken the same one. If you take 4 equals log base 3 of 81, you put it in exponential form, you're going to get 3 to the 4th equals 81. But I want to show you the process here, so I just made up a slightly different one. So the equation is log base 2 of 1/8 equals minus 3, which is true. That's actually what it equals, and we'll see why later. but I want to write that as an exponential equation. In other words, I want to get rid of the logarithm. And we do this a lot. If we're trying to solve an equation, we have a logarithm, we kind of like to get rid of it most of the time, you know, especially if there's a variable inside of the logarithm, right? So what I'm going to do is I'm going to compose this log base 2 with exponential function base 2. And the log base 2 will be the inside function. So the outside function is exponential function base 2. The inside of exponential function base 2 is the exponent. So if I'm sticking log base 2 of 1/8 inside exponential function base 2, then I'm making log base 2 of 1/8 the exponent with a base 2. So it looks like this. It's hard to follow orally without me writing it out, but I wanted you to try because it helps your thinking. So this is what I'm going to do. I just wrote out just part of what I just said. Okay, so that'll put the left side and the right side in the exponent, and with a base 2. It looks like this. So get used to how that looks. So I went from log base 2 of 1/8 equals -3 to 2 to the log base 2 of 1/8 equals 2 to the -3rd. So notice the two sides of the original equation became the exponents of 2. And there's only one base 2 on the left and one base 2 on the right for the exponential base 2, right? Now on the left side, that exponential function base 2 composed with the log base 2, that cancels, and you end up getting 1/8. And if you're confused about that, look back at the previous page if you're looking at the PDF. Just keep referring back to that. So I end up getting that. See? 1/8 equals 2 to the -3. And if you think about that, you should know that's true. 2 to the -3 is 1 over 2 cubed, which is 1/8, right? But you're not supposed to do that. You're just supposed to leave it this way. Okay, so the next problem we're going to do is this one. Solve. We're going to solve an equation. Woohoo! Later we'll do more solving of equations in the last section that we do in this chapter. But this is just a simple one. The argument here is 3x, the argument of the log function. It's log base 3 of 3x. Now, this is a convention that you need to know. If you have a product or quotient following the log base 7, then that product is considered to be inside the log. It's the argument of the log. There's a few exceptions to that, but mostly that kind of thing involves things like trig functions. And that's just because the reason we have these conventions is just to avoid writing parentheses so much if we don't need to. But you can put parentheses around the 3x if that makes you more comfortable. So if you see log base 7 of 3x, you can put parentheses around the 3x. What it does not mean is log base 7 of 3, like you'd calculate that number and then take it and multiply by x. That's not what it means. The 3x is inside the log function, not just the 3, okay? Anyway, they want you to solve. So I want to get rid of the log base 7 because I'm trying to get to the x. I'm trying to unravel things and get down to x equals something. So I need to get rid of that log base 7. And as usual, I'm working from the outside in, unwrapping the left side until I get to the x, the little jewel in the middle. So I'm going to compose both sides of the equation with the inverse function of log base 7, which is exponential function base 7. In other words, I make the left side of the equation and the right side of the equation exponents with a base of 7. Okay, make the left and right side exponents with a base of 7. It's that simple, okay? So it looks like that. Now the 7 to the log base 7, that part just cancels out. And you're left with 3x on the left. Equals, and 7 to the minus 1 is 1/7, which I am going to rewrite in this one because I'm solving for x. I'm not just, the previous two I'm just, writing the numbers in different forms, writing the little identities in different forms. This is actually an equation where we're solving for x. So I wrote the 7 to the minus 1 is 1/7. Then I just cross multiplied. The 3 goes down the denominator on the right. Right? Same as dividing both sides by 3. The 3 goes in the denominator on the right. So you get x equals 1/21. And that's my answer. And if we knew more properties of logs, we could check that. I guess you could check it. You could plug it in. You'd get 3/21 is 1/7. And the way to simplify things like log base 7 of 1/7, you want to try to write the argument as a power of 7. So that'd be log base 7 of 7 to the minus 1, which is -1. At this point, it might be a little hard. The thing is, if you wanted to try to put it in your calculator, most calculators do not have base 7. They'll have what's called base 10, which is usually just written log. They leave off the 10, kind of like we leave off the 2 in square root. Or they'll use log base e, which is the e that we used for continuously compounded interest, that e, log base e. And we'll see those are the two most commonly used logarithms. So those two are on your calculator. Log base 7 usually isn't. So you need to know your properties of logarithms, the two on the previous video, in order to even check that. So, well, to check it with a calculator. So see, I wrote that out for you. I forgot I wrote it out or I wouldn't have just said it. So it works like that. So you can look at that closely and emulate that when you're trying to check your answers. And remember, you want to get to where you don't have to look at it. You can look at this example maybe the first time you try one, but then always try more where you're not looking at my example while you do it. Because if you're always looking at my example when you work something out, you're never going to be able to do it on your own.